This is going to be a walkthrough for question 4 on the practice exam. So here we have Finn, the dog. We have his mass here, 25 kilograms. We have our energy, and he's jumping horizontally. This is also important. And we also have our height right here from the image. So the first part, question A, tells us that we're on a very massive boat, so the boat won't move as he jumps, which is important. And we have the height here, and we want to find the velocity that Finn will have once he jumps, so his initial velocity. We have our energy. We have our E is equal to our 450 joules, and we know that E is equal to 1/2 mv squared, so we can rearrange this to get our V. Our V is going to be equal to 2E over m, and we want the square root of that. When we plug our values in for this, we get 6 meters per second. Cool. For our next part, the boat is floating that far away, and we're wondering if he's going to be able to make it. These are like our old kinematic equations that we used to do. So the first thing we want to do is we want to solve for our time. What we have is we have all the information we need for our x direction. We have that our x of t is equal to negative 1/2 g t squared plus h. I'm getting this because we know that this is our acceleration and our height is the displacement. So when we plug in here, and our final y is going to be 0. So we can plug in, we get negative 5t squared plus h, and we're trying to isolate our t. Our h is equal to 1, so we get t is equal to the square root of, when we move this over, the negatives cancel, so we get 1/5. You can just pop that into your calculator. For our x direction, we just need our v, which we just solved for above, times our t. So it's going to be 6 times the square root of this, which should equal 2.68 meters, which is greater than the 2.5 meters, which means he'll make it. For part C, we have that the canoe is much lighter, so it has the same mass as Finn. Height stays the same, and the energy stays the same. So now we have to use the conservation of momentum to explain this one. We know that Finn and the boat have the same mass. I'm just denoting Finn as this square here. So whatever Finn pushes to propel himself outwards is going to be equal going backwards. So what that means is that whatever velocity Finn goes forward with, the boat is going to go backwards with. This energy that Finn is pushing onto the boat is shared equally between the two of them because their energies are the same. So what this means is that our energy that Finn has to jump and propel himself is going to be divided by 2 now, since it's getting spread evenly between him and the boat. So before our expression, we had v equals the square root of 2e over m, but now our e is halved, meaning that this factor of 2 goes away, so we just get the square root of e over m, and that should give us around 4.24. The velocity itself isn't halved, and that's because of this, the fact that v is squared. So don't just divide the velocity by 2, you need to specifically divide the energy by 2 because it's being split in half. And next we want to know again if he'll be able to jump on top of the Frisbee. There's no new information here. So we're just going to do the same thing again, but using this expression, but now we have a new velocity. So it's still just going to be VT, but now it's going to be 4.24 times the square root of 1/5, and this should give us around 1.9 meters, which is less than the 2.5 meters we needed before, which means he will no longer be able to reach the Frisbee.